Very good afternoon to all. So let us start the session. So before going into the session, can anyone can confirm? Am I audible to you all? Whether the slides are visible to you all?
Yes, sir.
Okay. Let me. So these are the topics we are going to discuss today in the software testing. We're going to discuss about the two types of testing: static testing, dynamic testing, and some of the tools and techniques which is going to help to complete the software testing, a traceability matrix, to know the relationships between various testing requirements and synthetic transitions, fuzzing, and we're going to discuss different types of testing like unit testing, installation testing, integration testing, and also about the alpha beta. So these are the various topics we're going to discuss in this topic. So first, software testing. So what is the purpose of performing this software testing? This is to know what is the quality of the software that is being developed within the organization. So this will help you to know about the various types of errors, the defects, the bugs, and will help the organization to know whether the developed software is fit for the business purpose. There will be an objective for each and every testing, and also like it will help you to get a kind of independent view of the software, whether it will allow the business to appreciate and recognize the risks. If there are many errors that has been identified during the testing phase that needs to be fixed before the release of that particular product. So you will be having a lot of coordinated procedures, like there will be a lot of tests will be executed on the application program. So basically to find the software bugs and also to validate whether the software product is fit for any type of purpose. It involves a series of execution of various components which will help you to evaluate one or more properties, and some of the components which will be under test is listed here. So first they will try to identify whether the developed software meets the requirements. For example, this may be your business requirement, this may be your contractual requirements, this may be your legal requirements or any kind of fiduciary requirements. So whether the developed product meets those requirements and as per the guided high level and low level design, because the requirements will be captured at the time of having the initial discussion with the organization. And also like they will be trying to test whether they are getting the desired outputs or the intended outputs for all kind of inputs. When I say all kind of inputs, it is not only for the valid inputs. Sometimes they give invalid inputs. Sometimes they give semi-valid inputs, because they'll be trying to identify how the application program responds. And also they'll be trying to identify whether it is returning the required functions within acceptable time. Sometimes the software may work fine when the number of records or the load is a manageable one. As and when the due to the scalability factor, if the number of the volume of business is going high at the time, the response time may be too large to accept by the user community. So also they will be trying to identify whether the required functions are providing the valid output within the acceptable time, and whether it is sufficiently usable by the user community. And also they'll be trying to test whether this can be installed on the intended environments. Probably there will be a different type of environment that may be used at the user community. They'll be trying to identify those, and also they'll be trying to finally gauge what is the general result that can be achieved from the stakeholders perspective. So there will be a lot of properties that needs to be tested during the test phase, and some of them are listed here. And there's a number of possible tests. Even for a simple software is practically infinite. When you say infinite, like you need to test all the parameters, all the components putting together. So you may not have sufficient time. Sometimes you'll be having very stringent deadlines. The production schedule may be very near. Probably you'll maybe given only 1 week or 2 weeks time. So at that time, the testing team may not have sufficient time to undergo all the tests, right? Also, sometimes the resources which is required to complete your test, that may not be sufficient one. As a result, the software testing, typically what they do, like they'll be trying to attempt to execute a program or application within the intent of finding the bugs. And it is a kind of an iterative process, I can say, because when you fix a bug, it may eliminate other. Probably this could be a deeper bugs also. So when you perform the regression test, what is the major objective will be like whether the newly introduced, probably the altered code should not introduce another bug, another kind of an error in the software. So it is very important to know if there is any change in the software code. Once intend to fix a bug, this should not eliminate other, or it can go into a kind of a deeper bugs. So every software testing will be having a defined objective, and also will help you to improve the quality of the software, also to reduce the risk, and also like it will help you to understand the value from the user perspective as well as from the stakeholder perspective. There are many types of testing you can perform in this software. Like basically, you need to conduct the test as soon as possible when the software is completed, or sometimes partially. There are many type of testing. For example, unit testing. Once a specific module is developed, right, the testing team can test that particular module or a function. No need to wait to complete the entire application program, right? So there are many types of approaches are there in the software testing, which will help them to conduct various tests as and when that is feasible for them to check, right? And another example here is a kind of a staged process. So when you say staged process, they'll be waiting for a particular stage to be completed, so that you'll be having a well-defined system requirements have been completed, and you can have the use cases where you can test and you can implement the various testable programs. There is another approach called as agile approach, right? Sometimes you'll be getting the requirements on the fly. Probably you're in the middle of the application program development. Few requests may come in even in that time, and the development team will be incorporating those requirements also. So kind of they'll be they'll be accommodating those requirements also. Like even the testing also can be done concurrently, so they do not wait for a particular stage to be completed. So like they'll be even initiating some of the tests for the completed modules, so that they can be ready for the business requirements. So two type of testing we just discussed. One is the static testing. The other one is the dynamic testing. So this is static testing. It is a kind of a technique in which the software is tested without executing the code. Absolutely, software is not executed, and there are many tools available which will help you to find many type of errors or bugs within the software code. And also you can refer the various documents, like the SRS documents, the software requirement specification documents. And design, again, you'll be having two types of documents. One is the high level design. Second one is a drill down low level design. And then only your coding process starts. And also there'll be a lot of test cases, a lot of use cases will be documented. So in a structured manner, the testing team will be looking into these documents and they'll be performing those tests. In static analysis, the code written by the software developers or analyzed by various tools. And we do have manual tools, we do have the automated tools. So basically that will look for any kind of a structural defects that may lead to any kind of defects within the developed application program. So static analysis will help you to basically to identify any kind of structural defects. And there are many types of reviews when we go for the static testing. It starts from the informal way of testing. There is no formal testing procedures have been identified or defined. Informal, the lowest level of I can say the testing can happen. Second one, structured walkthrough. So you'll be having the defined walkthrough kind of an exercise that needs to be performed to complete your testing activities. Third one is a peer review. The team which developed the application may not involved in the testing. That will be given to the another team which is having at par the technical skills to perform the testing. So kind of a peer review that can be given to the another team. So basically they'll be performing the testing. And finally, a formal inspection testing procedures. So this is a level of formality. You'll be having four types of reviews that can happen in the static testing. So now we are going to discuss about what are the various types of defects that can be detected by the tools when we follow the static testing methodology. First, they'll be targeting a variable with an undefined value. A variable may be declared, but you'll be fine. Nowhere it has been the value is defined, undefined values. Inconsistent interface between various modules and the components. Sometimes you'll be fine. A variable is well defined, declared, but it is never used within your program. Unreachable code, dead codes. Sometimes the logic may not hit by the application program, and those codes are called as an unreachable codes or dead codes. So then programming standard violations. There will be a programming standard, and if there is any kind of a violations that can be identified. Security vulnerabilities, very specifically some of the application related vulnerabilities, then syntax violations or errors or even typo errors. So these are the various types of defects that can be identified when we use the static testing methodology. Dynamic testing. So when you say dynamic testing, like basically this is to know how the application behaves. This is done by executing the application, because in the previous case, static, the application will be static. It is not executed. But however, dynamic testing will help you to run the program, run the application, and then you'll be trying to identify or trying to observe the behavior of the application program, how it behaves, and how the various output that you're getting from the application program. To perform the dynamic testing, first the software should be compiled and then executed with different parameters. For example, you need to observe the memory usage. You need to monitor the CPU usage. And how about the response time from one module to another module, as well as the overall performance of the software or the system that are very precisely analyzed. And also this dynamic testing involves the test software for the given input values, and they'll be observing what is the output they're getting and how they are going to properly analyzed. It's a kind of verification, validation of those output with the expected results. So two types of techniques here, like which will help you to complete your dynamic testing. One is a functional testing. When you say functional testing, the requirements that will be from the business. Non-functional testing, it is not directly related to business requirement, but however, there are many other requirements which we need to have in the application programs and non-functional testing. The technique to use the features but the function of the software, right? They'll be trying to cover all the scenarios, including the failure paths also. Sometimes the use cases may not provide you kind of wrong inputs or invalid inputs or semi-valid inputs. Always they'll be trying to provide the valid inputs, and they may be getting a positive results. But we need to cover the various scenarios where this will be even a kind of a failure paths also. and also the boundary cases. The boundary cases within the range. For example, if there is a parameter given 1 to 100, so they'll be trying to identify even the boundary cases also. So not only the exact values for each and every variables. And to perform the functional testing, there are two types of approaches that has been displayed here. One is a black box testing, other one is a white box testing. So when you say white box testing, like all the information will be known to the testing team, and they'll be having complete access even to the documents. They'll be having access to the system. They'll be having access to the source code, and they'll be having complete information like a development team. The testing team will be having all the information. When you say black box testing, it is like very little information or no information provided to the testing team. All they know to provide the input, and blindly they'll be evaluating the output. The two types of approaches if you want to perform the functional testing: white box testing and a black box testing. Other major functional testing like unit testing, integration testing, smoke testing. In the coming slides, we'll be discussing the major testing types. Unit testing, it's a text testing technique, you can say, like whenever the individual modules have been completed, and this will be done by the development team itself. In most cases, the senior developer within the team will be requested to perform the test, and they'll be trying to test the particular module. And once it is success, then they'll be proceeding with the other modules. So unit testing will help the developing team to identify any type of errors or any kind of defects at the early stage itself without going to the next module. And it is generally concerned with the functional correctness of the standalone modules. For example, in a particular module, you may be having 3 or 4 requirements, and they'll be trying to fulfill all those requirements. And once it is done, then they'll be trying to test for the particular module. And the main aim objective is to isolate each unit of the testing to identify, analyze, and fix the defects. Because sometimes when you integrate various modules, and you may encounter a lot of defects. At the time, it will be very difficult and complex to identify which module is getting failed. You have to perform a lot of debugging activities to know where exactly the error is happening. Sometimes error may happen in 4 or 5 modules, right? It will be very difficult for you to identify in a complex nature. So in order to avoid those challenges, it is advised to test each and every module so that the developing team will be having a kind of a handful of information that this module is tested and it is working fine, so that they'll be having a complete information about it. So the unit testing will help the team to test each and every module as and when it has been developed. Integration testing. Once all the modules have been developed, what they do, like they try to combine, they try to compile, and they'll be performing the test as a group. It is conducted to evaluate the overall compliance of the system of various components, right? So once the unit testing is successful, then they'll be going for this integration testing before the validation or before the system testing, right? There are many types of I can say various stages. The first one is about the unit testing, and second one is about integration testing. Like what they do, like they'll be integrating many modules and functions together, and they'll be trying to test, evaluate the overall compliance of the system. So once the output that is being delivered in the integration testing, then it will be ready for the system testing. In the system testing, you are going to test even the memory, the CPU usage, the response time, and the stability of the system, the robustness of the system, not only the functional requirements, but also you'll be trying to test the other parameters also. Smoke testing. It is very kind of a preliminary testing, you can say, which is used to reveal the simple failures severe enough to reject a prospective software release. Many Projects have been delayed to production because there is a failure in the smoke testing, because they will test only the very critical requirements. Even if one of the module is getting failed, the release of the product will be delayed. And smoke tests are a subset of tests that cover most of the important functionality, I can say, like which will help you to know whether the main functions of the software appear to work correctly or not. Because these requirements will be very critical for the business. If it is not corrected, then probably the release of the product itself may get postponed. When used to determine if a computer program should be subjected to further, more fine-grained testing, smoke test, maybe even it is called as a intake test also. Like, so very important, the smoke testing should get a successful note before getting into the production environment. Then UAT, user acceptance testing. It's a process of verifying that a given solution, or the developed application program works as per the user requirement. So it will ensure that the solution is working for the stakeholders. For example, the software vendor, even they call this as a beta testing. Whatever test that we are going to make in the developing side is alpha testing. Then whatever test we are going to perform on the customer side or on the user environment, that is the beta test. So there are different type of testing: alpha testing, beta testing, gamma testing, right? So here the author is referring this as a beta testing. So they are trying to make a testing activities which will be accepted by the user community. And generally this testing will be performed by the SMEs, subject matter experts. They know like what they are requested for, and verifying, after validation of the output, they will certify. They will certify that this is the one they are looking for in their business requirements. And also they'll be providing a summary of the findings for confirmation to proceed after trial or review. So very important UAT test. And also there are many software projects may get delayed or denied even if there is any challenges in getting the successful results of the UAT. And in software development, UAT is one of the final stages before putting into the production, because this is like going to be accepted by the client, accepted by the customer. And also this UAT will be performed in a kind of a real life scenarios. I can say, when I say real life, it is a kind of the production environment, how it has been established in the user community. And also it is very important to test from the user community side using the real life scenarios, or you'll be finding the kind of the data that is going to be used, and the system, the configuration, it will be kind of a replica of your production environment. So after completing the functional testing, they'll be also performing the non-functional testing, because various attributes cannot be tested in functional testing. For example, memory leaks, performance, performance of the system, because sometimes the module may work fine in unit testing. Even you'll be getting a successful in the integration testing. But when you perform the testing as a whole, as a system, you'll be finding the system will be very sluggish, or you may not get the response within the stipulated time, or probably it may lead to a kind of an error, or the system may go into a hang status. So the robustness, the performance cannot be tested in the functional testing. So there comes your non-functional testing. And also we are having a lot of types in non-functional testing. For example, the baseline testing, compatibility, load testing, localization testing, resilience, security testing. So these are the various types of tests which will help you to evaluate the overall system performance, the robustness, the reliability, and the usability, the volume testing. So depending upon the requirement, not all the organization will be going through all the types of tests. Depending upon their requirements, depending upon their the objective of the test, they'll be choosing one or more types of non-functional testing, and they'll be performing it and they'll be satisfying it. So now we're going to discuss about the levels of dynamic testing techniques. The first is a unit testing, we already discussed. Then integration testing, we discussed. System testing as a whole, about even the system performance. Then about the acceptance testing from the user community. So even these are the four levels of testing that will be performed in the dynamic testing. So do we have any doubts, any queries from anyone so far?
How it's different from SAST and DAST testing, sir?
Yeah, SAS is like you are not executing the application. You are just performing a kind of a code review, or you are trying to identify some of the text string, and structural defects can be identified in your SAST testing. But the behavior of the program you cannot test in the SAST. Whereas in the dynamic testing, you are allowing the program to run. You are able to identify what is the response time. You'll be able to identify the behavior of the system as and when you add more business traffic or the records. So exactly, dynamic testing will help you to understand the behavior of the application program. So that is a major difference between your static and the dynamic tools.
So what you so far we saw in the slide something different or one of the integrated components, like what on previous slides, whatever testing we saw and currently what is visible, everything is interrelated, sir?
Yes, everything is interrelated. Everything is interrelated.
Okay, got it. Thank you.
Thank you, Mr. Vivekanandan. Thank you. And we'll move on to the next topic, traceability matrix. Actually, this is a kind of a document. I can say usually this will be represented in the form of a table, because in a complex project, you need to know about the various relationships, and also you'll be having a lot of reference where we need to know that whether the particular test has been completed or not. You'll be having the high level requirements, and also you'll be having kind of a relationship between various type of tests. For example, the unit testing, the integration testing, the compatibility testing, the installation testing, like that. Each and every testing will cover certain properties or certain requirements or the components of your program. So this will be a kind of a matrix, and you'll be able to mark whether that particular test is completed or not. So kind of document which will help you to complete. That is what the traceability matrix will be used for. So you'll be able to identify the various requirements like high level design, the low level design. Also, you'll be developing a lot of test plans and test cases, the use cases before the testing, and you'll be able to develop a kind of a traceability matrix, which will help you to check if the current project requirements have been met. Sometimes there'll be a lot of other requirements, but whether the current project requirements are test met, because in a baseline requirements you'll be having 10 or 12 parameters, but in your project the critical or the requirement will be only 6 or 7. So whether those 6 or 7 will be completed or not, because this will be created at the time of the proposal itself, to your project proposal, and also the SRS documents, the software requirement specification documents. So the major, I can say, the common usage is to take a kind of identify each and every items in your document, and you'll be able to mark whether this is completed and this is pending, and this is like in the pipeline, like, which will help the project team to understand those types of tests. And also they'll be finding some kind of relationships to the source documents, like which will help them to trace backward and the forward also. So next topic we're going to discuss about the synthetic transitions work, because many times like you'll be performing a kind of large volumes of tests which will be dedicatedly that will be test with both parameters. One is for the performance of the system, other one is the availability of the your applications from a very remote sites. Sometimes there will be no traffic, or sometimes the traffic will be at peak, right? Sometimes you'll be having the moderate kind of a traffic that will hit on your web servers. So simply deploying the scripts onto a web browser, this is help you to simulate a kind of a path where a real customer takes or making of your the service. So what they do, like they'll be trying to kind of understand the various types of the loads that is coming to your business, and they'll be trying to perform, because the top reasons is like there will be a lot of SLAs will be agreed between the service provider and the customer. Like when you say the SLA, service level agreement, so what is the service level objective, and about the availability of the service, and also the scope what has been agreed for that particular service. And also during the time of any kind of incidents or interruptions to business, and what is the SLA matrix that will be followed. For example, what is the response time and the resolution time, and also like the kind of escalation matrix. So who will be involved if the incident is not resolved with that particular time frame, and how the escalation will happen. There are two types of escalations: one escalation for resolution, one escalation for notification. Because sometimes if the service is interrupted for a longer period, then the stakeholders needs to be informed, right? So all these information will be clearly defined and documented in your SLAs. So that is one of the reason why the synthetic testing will help to measure the performance of your service if there is no traffic, if there is a high peak traffic, and if there's a moderate traffic from the remote locations. And also this will help you to monitor the web applications during the peak hours, the off peak hours, the traffic periods, various types of I can say in a global business scenario, like sometimes you'll be having the peak hours, sometimes you'll be having the less. So this type of synthetic testing will help you to monitor both the extremes. Then also it will help you to benchmark trends across geographies, because certain business you'll be getting more traffic from a specific region. So how you're going to test. So this synthetic testing will help you to even benchmark the trends across various geographies, and if required, then you'll be adding more resources to support those requirements. And also test to business web services if more integrated services have been provided to them. And SLAs, very important. The key, I can say, the information that will be documented, and it will be a kind of a, I can say, the transparent document between the service provider and the client who is getting the service, because they'll be finding the service level objectives. And purely this depends upon the type of service that has been subscribed. If they have subscribed a gold or silver or platinum or bronze, for example, what is the availability of the server that is being serviced, that has been agreed? Is it a 99.9999, or it is 97.5, or it is 95? It depends. It depends upon like what type of subscription so that has been subscribed by the client for that particular service. And this is about measuring the SLAs, very, very critical, because you'll be having a number of third parties which will help you to host the particular one. And also you need to know about how the performance of the service, and about the stability, and also the transparency. Sometimes if the service is going down, like, so which vendor is responsible for fixing the particular incident, or which is who are responsible for the resolution of that particular interruption. And also it will help them to validate the performance to ensure the client is getting the consistent delivery of those services. And also like SLAs is been mentioned here, there are a lot of OLAs also, the operating level agreements, because when you say SLA, it is between the service provider and the client. And you'll be in between, you'll be having a lot of internal teams also will be working towards a service. There comes your operating level agreements. For example, you may be having the network team who is responsible to provide the networking requirements for that particular service. And you'll be having very specifically the other technical team who provide the other technical supports. So you'll be having a lot of I can say the internal teams, and that will be driven by your OLAs, the operating level agreements, and we do have the UCs, the underpinning contracts. Sometimes you'll be having the external vendor who will be involved to provide a kind of a part of a service. So your underpinning contracts, your OLAs, your SLAs. So when you go through all these requirements, then you'll be trying to identify like how the service has been provided to your client from the customer point of view. So do we have anyone working in this environment, like identifying the SLAs, the OLAs, and the underpinning contracts, which is very, very critical for delivery of any kind of a service? So do we have anyone in our team here to shed more light on these terminologies, SLAs, OLAs, and underpinning contracts? Because for any service, this is very, very critical. And SLA is I can say, a kind of document which will help to have a transparency between the service recipient and the service provider. What type of service is going to be provided, and what is the service level objective, and if there is any interruption, and what is the process to be followed. And also, many organizations will be trying to keep up their SLAs because if there is an unplanned downtime, they will be responsible to attract many penalties also. Sometimes the invoicing will be having the parameters of the penalties also. Sometimes if the server is down beyond the agreed service level, for example, if the agreed SLA is 99.99 and the server availability is calculated to 97%, then the vendor will be taking a hit in their invoice because the service is not available. So very critical to understand the various services. Then next we are going to discuss about the another requirement, monitoring the web applications during the peak and off traffic periods. Because the application these days are not a standalone. You'll be having a lot of components which interface each other, and also you'll be finding a lot of web services and various protocols will be running. So the service provider should assure that all these components work perfectly fine when they're integrated. From the customer standpoint, probably it may be a single service, but you'll be finding even a lot of more vendors. The various components will be integrated and work together. So when we are using the synthetic testing, like you can able to measure the application performance 24/7, every node, every point. And also you'll be trying to even analyze the various alerts, the different, the responsible team be able to get if there is any kind of interruptions or any kind of um, I can say like interruptions or incidents to this particular service, which may affect the end customer, which will help you to explore in production environment. And also like you can able to schedule various tests according to the geographical regions, and also to know about the high traffic period for a particular geographical location, and help you to benchmark trends across geographies. Since we have the scheduled arrangement for testing for various regions, then the system will help you to capture the various test results, and it will help you to benchmark the trends across various geographies. Test various business services. For example, some of the web services like SOAP or REST or any other web technologies, and also like how the communication is happening for both upstream and downstream. And also sometimes they'll be trying to reuse those existing web services for multiple workflows within the service. So after synthetic testing, we're going to discuss about the fuzzy. So fuzzing is like it will perform in automated manner, like automated software testing technique, which provides invalid or unexpected, or sometimes it will be random data as input to a computer program. The system may not receive any regular inputs, right? It will be a kind of an invalid inputs, and also this will be done in an automated manner, and also the large volume of inputs also. And the intent is to know whether the system is getting crashed, or the system how it performs when you give those kind of an inputs. The overall program is monitored for any kind of an exceptions or kind of crashes or any kind of a potential memory leaks. The kind of structured inputs also they'll be trying to test in the fuzzing tests. And very important to know about how it is going to handle these various types of inputs. It can be categorized in many ways, like it'll be kind of a generation based or mutation based, whether they will be going to start from the scratch or from the modified existing inputs. Sometimes they'll be getting a result from the previous test, and based on the outcome, they'll be trying to modify the input for the next test. So kind of I can say the serial based tests also available. And fuzzer can be a dump or smart depending upon whether they provide the input structure about to the testing. And all the different types of methodologies will work for fuzzy testing. For example, it can be a gray box testing or white box testing or a black box testing. All the three different methodologies can be used for fuzzy testing. Mostly this will be kind of an automated technique which will help you to expose various type of vulnerabilities in the critical programs. And fuzzing will help you to demonstrate the presence of bugs or errors rather than their absence. Like it will help you to identify. And sometimes this may even run even for several weeks also. The next topic is about exposing the bugs. So this is to like distinguish what is expected and what is unexpected. From the program standpoint, they'll be trying to identify.
Can we call
Yeah.
the first testing as a negative testing, sir?
Which testing, sir?
First testing.
Yeah, to call fuzzy testing to call
Negative testing.
negative.
Negative.
Okay, in the sense like yeah, we can say that also kind of a negative testing. You're trying to identify uh, the bugs or the errors in the program. Yeah, you can call that as a negative testing also.
Yeah, basically, it seems like more of the bugs that are hidden in the application.
Yes.
Usually, any people used to test, right? They will use the actual inputs to test the as per whether it is working as per the functionality. But the first test seems to be more of trying to identify the internal bugs or the behavior of the system. Basically.
Yes, exactly.
That is where they are trying to give the inputs, right? Most of the values that they give are more of
Yes.
invalid inputs.
Yes, invalid or yeah.
How,
Yes, Mr. Shiva.
And see how it behaves, how the system behaves to the situation.
Exactly. Actually, you are expecting the system to get crashed. Yes.
That's correct. That is right. Sometimes
exactly.
What would happen? Suppose, say, for example, if you upload a file
on
the system, right? So during the time, there may be some allowed extensions.
Yes.
Right. What would happen if you are giving some sort of, some other type of files that are being uploaded? How the system behaves?
Yes, exactly. Exactly, Mr. Shiva. Yes. So thank you for sure. Yes, exactly. Actually, you are trying to identify whether the system is getting crash or what is the response of that system by deliberately providing invalid inputs or semi-valid inputs or unexpected inputs.
That is where what they will do, sir, basically. So they will have a list of values or the inputs that are not valid at all, and they will try to have
Yep.
all those things in a Excel sheet or something. Okay, so that the automation tool will pick up the data from the sheet and it will try to
Yes.
put on the system and see how it behaves.
Exactly. Exactly, Mr. Shiva. Exactly.
And also there was one other question asked that is more on the static testing. Basically, static testing comes under two areas. One is more of the quality aspect. Quality aspect in the sense what are the code the developer writes.
Yes.
We are looking
Yep.
for a quality code. For that, there are a lot of tools like SonarQube. SonarQube is one, and Codis is another tool. These are all the
Okay.
tools that will do the static analysis of the code and tell that what are all the issues that they have to fix on the code. Basically, if they are not handled the exceptions properly, then it will message or record it as an exception not handled properly. Okay? And also, the
Okay.
variable has been declared and it is not being used anywhere. Then again,
Yep.
it will show one another message. Okay? So this is one of the static and static code, static testing. The other part is more on the security testing. That is where the 45 comes in the picture. 45 check marks and other tools, right? Those all comes in the picture.
Okay.
That will also do exercise the code. Okay, if the code needs to, I mean, which means that it is not on the runtime. It's not on the runtime environment. Code will be that
Okay.
is that static testing comes into picture. Code will be as it is on a static file that will be considered by the uh, scanner, basically the tool scanner. It will scan each and every line of the code, and finally it will generate a result. These are all more of
Okay.
the security testing. So static will comes under code quality as well as it comes under security testing also.
Okay. Okay. Good. Good. Good to
So
know, Mr.
yeah,
Shiva.
thanks.
So you.
Someone has asked
So
a
basically,
question.
you. Okay. Basically, you are from the testing team.
No, sir, I am working on the application security system. I
Architecture.
have the
Okay.
background of
Okay.
testing. Yeah, I have the background of testing as well.
Okay. Is it a manual testing or auto testing?
Automation,
Automated.
automation, automation, automation,
Automations.
automation. But I
Okay.
am currently
Okay.
working
Great.
on application security.
Okay.
Absolutely.
You're taking care of application security now. Okay. 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 Great. Great. Great.
Nowadays, because of the DevOps, right, sir, the recent developments on the agile framework and the DevOps comes into picture, all the tools have
Yeah.
been
DevOps.
continuous CSE, continuous
Yeah.
integration, continuous development. So once the code promoted to the repository, right, there are automated jobs. Will be there. So what it will do, it will
Okay.
try to pull the code and will do the code quality analysis, basically using the SonarQube. Okay, then once it code quality passes, then it will go for the unit testing. Or unit testing, they use JUnit or some other tools to perform the unit testing. Once it is done properly, or 80% of the test case has been passed, then it will go for functional testing. Then again, it will go for a security testing like a static testing, like I said, right? So 40 check marks or whatever the tool they are using on the automation that can be used. And again, it will go for the open source scans. Open source scan is basically for whatever the components that are being used by the public developers, basically. So for a rapid development, or they don't want to write any language, it is already there as an open source. They can consume all the open source that are available so that they can do open source scans. So if
Very good
everything
information.
goes fine as per the expectation, as you said, right, sir, you said that there's some
Yeah.
SLA, right? Here the SLA for these activities is going to be 80%. So once unit test case is past 80%, then it goes for functional testing. Once the functional test has
Okay.
been passed, then we go for the next job to run. So like that, they may have some stats as well, sir. So everything has been integrated in the continuous integration, continuous integration, continuous. And it's basically called a CSED. We can use Janity or TCP or Bangalore or any other CSED for this integration.
Very good, sir. Good information. Good information. So this will be very beneficial for all the participants here to know about having the complete insight about the real testing activities.
Since one of the person asked about static, so the static
Yes.
testing falls under two categories. That is what I want to allow you.
Yeah. Yep. Thank you, Mr. Shiva.
That's it.
Thank you, Shiva. Thank you. So probably this could have given more information to all the participants here about the static testing as well as the other the real requirements in the dynamic testing.
So dynamic testing serves there are two part of it, sir.
Yeah.
Basically, they will do the dynamic testing using some tools. Okay, and the other part of it is more of the DAST, that we call as DAST, dynamic testing.
Yeah, DAST.
Security testing. That is
Yeah.
where tools like the penetration test comes into picture. So the code will be actually it is not a code. So it will be deployed as a build, or basically it will be built and deployed as a var or jar file. So the application will be on the running state. Okay. So basically we will try to intercept the request what goes to the server and try to do some sort of changes on the request that we are sending and see how it behaves, how the server behaves.
Okay.
And also on the security aspects, they will try to inject something, basically scripting scripts or something or any values that can be injected and see whether they have done the proper validation on the application or simply accepting and processing the data.
Okay. Basically, they'll be trying to perform a SQL injection or a command line injection or any other kind of application with vulnerabilities.
Yeah, cross-site scripting, command.
Yeah, cross-site scripting, CSRF. Okay.
Yeah, misuse it upload.
Yeah.
So all those things will come. Session hijacking, session fixation.
Okay. Great. So basically, the top 10 OS vulnerabilities also.
Yes, sir. That is how the organization basically they are targeting the top 10. Yeah, but yeah, all the tools have the ability to customize the rules as well. So every year they will be releasing the top 10 awards, top 10. So based on that, they will try to prioritize the vulnerabilities, basically the application vulnerabilities, and they will use for that.
Okay. Okay, great. And whether in reality all the tests will be conducted or there will be compromise with a couple of tests before production.
No, sir. Actually, as per organizations have different strategies, sir. Have different strategies and different policies, basically.
Okay.
So,
okay.
In our company and all, if there are any criticals, basically on the security testing, we are not allowing them to go for production.
Okay.
Unless it is approved by the respective VP or someone who is taking the responsibility to anything goes on production or in security aspect, then that person has to take the complete liability. So otherwise you don't go for production.
Okay. Because there are a lot of, I can say from the functional testing, not on the non-functional, because security cannot be compromised. On the functional testing, we have a lot of type of testing, which will take a lot of resources, lot of time requirement for to complete those testing. So probably it will be a kind of the organization strategy.
Yeah, that depends upon the situation, sir. It's all about the business impact they have.
Yes.
So in case of any product that comes into the market, okay, and they are working on to sell the product, right? So everybody will be most of the let's take Amazon. Okay, Amazon, the Flipkart, all of the people are trying to take the orders, right?
Yes.
So if they don't have sufficient time to complete the testing, at least if 80% of the testing are done, then they will go for the production. They don't give the customer because of the.
Yes.
If the core functionality is working and some of the functionality may not be working, right? So that is not a problem for them. Still, they will let or development team work in the meantime, but again they will go for production.
Okay. Kind of they will be releasing the future versions. Yeah.
Correct. Feature versions. It's not about the features, sir. If you take Amazon and all, right, sir, they will be doing more thousands of deployment in a day.
Yes. Yes. Because they cannot stop the production. They cannot stop the production for
Yeah. Because otherwise they lose the customer. They want to sell the
Yes,
product, right?
yes, yes. And also availability is one of the greatest factor for those business, e-commerce business.
E-commerce, correct. Yes.
Uh, the availability of the service
The
is very, very
e-commerce,
key for them. Yeah.
correct, sir. The e-commerce platform is always hot, sir.
Yes.
Hmm.
Yeah. Good to
So
know,
again,
Mr.
let's
Shiva.
go with that. Thanks, sir.
Thank you very much, Mr. Shiva. Definitely, your input to this session. Definitely, all the participants will be getting benefited.
So it's a great opportunity for me to share that.
Always welcome, sir. Always welcome. And we can go to the next topic. Um so this is about exposing the bugs. So there are different types of sanitizers that will be used for different types of bugs that can be identified or detected. So first they'll be trying to detect memory-related errors, a kind of buffer overflows. Then they'll be trying to detect some kind of race conditions and deadlocks. Sometimes the resource will be waiting for another resource, and it'll be kind of a deadlock situation where the application will be going to a hung status, or sometimes it'll be an undefined behavior, or any kind of memory leaks, or the control flow integrity. So there are many types of different types of bugs that can be identified, and all these things from the fuzzy testing. All these things from the fuzzy testing. So they'll be trying to detect many differential bugs, kind of automated differential testing that will help to provide various inputs and execute it to on two different implementations of the same program. And then next about how do they validate the static analysis report? Because after getting the reports, you'll be finding a lot of false positives also. Sometimes there could be many false positives from the tool. Actually, the particular bug may or may not exist in that. So how they can able to determine this is a false positive and this is a true positive, again based on various parameters. And they'll be using various combinations within the dynamic program analysis, and also they'll be trying to generate the input actually what they witness from the reported problem, and they'll be trying to validate it. Is it a true positive or is it a false positive? Because false positives is going to be one of the kind of I can say the challenge for the testing team to quantify or to determine is it a true or a false. And next we're going to discuss about the browser security, because browsers also will be undergoing a lot of extensive fuzzy tests. I can say here, like for Microsoft Edge and Internet Explorer, Microsoft, they nearly used 670 machine years during the product cycle and more than 400 billion DOM manipulations from 1 billion HTML files. This is what like the volume they've given for testing their browsers. Especially this is for the browser security. And in 2016, Google they mentioned like they spent around 4 trillion inputs a week to test the Google project. And this is from the Microsoft security research, given the about how they determine from the crashing input, like how they can assign the exploitable rating. Is it exploitable? Is it probably exploitable? Some of the errors or bugs, even the vulnerabilities that has been identified. How do they rate those findings? Then there are different types of specific testing. Because basically the testing will help to determine the correctness of a software. Like sometimes whatever defects, whatever bugs they identified in the testing that needs to be corrected before release of the product. And primary testing is to identify the defects so that it can be corrected. And also, like, it has to be executed in the various environments and the various conditions, because they need to perform the testing from the aspect like what it is supposed to do and what it needs to do. Kind of they'll be even understanding the behavior of the application and about the output for a specific input, like that, for various requirements. So there'll be different types of purposes to perform the specific software testing. And also you'll be finding the various roles for the testing team members, because each and every product that has been developed, they'll be having a target audience. For example, for one of the game, video game, there'll be different types of audience, and another side you'll be having the banking software, which is developed for one of the banking customer. So you'll be having different types of target audience, and depending upon their requirements, the various modules, the functions that will be tested from the user community side. So basically, the testing will be performed from the target audience side, or it could be the purchasers or the relevant stakeholders. And not all software defects caused by the coding errors, because one of the common myth here, like, if there is a mistake in the coding, then it will result in a software defects. But here the author is mentioning it, right? Not all software defects that caused by the coding errors, because one of the common source, like, will be kind of a requirement gaps. Sometimes the documented SRS document may not give full information, and sometimes it could be an omission by the programmer designing. And that also one of the requirements. And other requirement gaps can be kind of non-functional requirements, could be a scalability or testability, performance, maintainability. And software faults, basically this will be kind of an error from the programmer, which will be resulting in a kind of a defect or a fault. Major, the major will be like in the software source code. And if a defect is executed in certain situations, the system will produce wrong results, causing a failure. A particular module will fail to provide the expected results. And some, for example, some of the, not all defects will necessarily result in failures, because sometimes in the dead code there may be a that may be an error, but in reality probably it may not be reached at all. So defects in the dead code will never result in failures, because never ever we are going to reach the dead code or the unreachable codes. And some of these changes happening in the environment will be like help. They'll be trying to test in the new hardware platform also. Sometimes they need to alter the source data, or in the way how it is interacting with the different software. Also, they'll be trying to perform a test. And a single defect may result in a wide range of failure symptoms. And they'll be trying to test all the possible combinations here. Like sometimes, like it will be a strict project deadlines. The testing team may not have sufficient timeline that has been given to them for completing all the tests, or it could be one of the strategy that is followed by the organization to choose some of the options that they have in the testing, and they'll be completing that. Or sometimes it will be a insufficient resource within the testing team to complete those testing. They cannot test everything. Like they'll be, what they do, like they'll be trying to perform a kind of a combinational kind of a test to identify the minimum number of tests, and also they want to have cover the maximum coverage, choosing the appropriate testing types. They'll be trying to cover the maximum coverage, and they'll be releasing the product. So there are basically different types of testing levels, as we just discussed. Three levels of testing: unit testing, as and when the module has been developed; then integration testing, various modules once it has been developed, that will be integrated, that will be tested as a whole; and a system testing, after compiling the entire program and they'll be even trying to evaluate the behavior of the system also as a system, how it behaves, the application program. And the another level, the last level before putting into production, is acceptance testing, the UAT tests. And like the operational acceptance testing, like it will be a simple end user testing, kind of a beta testing, what they're going to perform on the customer site, I can say on the production site, the kind of the fourth level acceptance testing. Unit testing, we already discussed, kind of testing the particular functionality within the particular section of the code at the functional level. And mostly this will be done by the developing team itself. So it's a kind of a white box testing because they have the visibility of the entire software code. They have the requirement specifications document. They have the high level design, low level design, the business requirements. So it's a kind of white box style. They're going to perform the unit testing. And unit testing alone cannot verify the functionality piece of a software because it has to be kind of I can say the building blocks for the entire software. And the assurance what we get is this particular module is functioning well in an independent manner once it has been developed. Then later this will be integrated with the other modules and they'll be performing the integration testing. And unit testing aims to eliminate the construction errors before code is promoted to the additional testing. The next type of testing is integration testing. And also the unit testing will help you to increase the quality of the resulting software because we are testing each and every module first. Then we are going for the next level of testing. So basically this is going to enhance the overall efficiency in the development process because the error which is identified at the early stage, then it can be rectified with less efforts. But once if you identify a bug or an error at a later stage, at the time of before release to production, then you need a lot of efforts, a complex kind of efforts to fix it. So it is very, I can say, kind of one of the primary requirement for the organization to detect the bugs or errors at the early stage itself, at the time of unit testing itself. And depending upon the organization expectations for the various software development, for unit testing, they may include static code analysis, data flow analytics, metrics analysis, peer code reviews, as well as the code coverage analysis. They'll be going through the entire software code and they'll be performing the analysis. The next type of testing, installation testing. So there are very the main purpose is to understand about how the system is the entire application program will take care of all the installation requirement. For example, sometimes this will be a full program deployment or could be a kind of an upgrade to the existing application. Or sometimes if the user wanted to uninstall and they want to install the another version of the same program. So in those scenarios, how the installation testing is going to help. And if there are any kind of an errors, because sometimes if you want to upgrade to the next version, so some of the previously installed modules needs to be removed completely. Then only you'll be able to, the system can able to work fine. So those requirements will be verified and tested in this particular installation testing. Some of the examples, a user must select a variety of options. And also the some of the setup files also will help to identify. For example, if you are downloading an application or a different software, first it will try to identify what is the hardware, I can say the configuration of the particular device in which the application is going to be installed. For example, is it a 32-bit or 64-bit? And like, what is it, a Windows operating system? Is it a different operating system? Like that, the basic identities of the system that will be identified, and based on that the supported application or the programs that can be installed on that particular device. So depending upon the various files, the dependent files, the libraries that needs to be allocated, loaded, and also properly it has to be located. And valid hardware configurations must be present. It will verify whether the intended host is having the basic hardware configuration requirements, whether it has been met or not. Then also the software systems that may need connectivity to connect to the other software components and the other systems. It's a kind of activity-based approach, say like how the testing is going to happen in this installation testing activity. For example, the installation of this software, it can happen in various ways, like how this can be installed. Sometimes it can be added or it can be changed. Does the installed software work, or what happens when you uninstall? There's all the associated files that's been completely removed from the system. So like that, they'll be trying to perform all type of tests. This generally takes outside of the software development environment. So this is to limit the code corruption, or I could say from the future or the past releases. And also they'll be trying to identify which is the right version that needs to be used for that particular host. An installation approach, like first they'll be trying to run an installation program. Sometimes it will be called as a packaged software. It could be your MS.c package or any other exe, which will typically kind of set up program, and also which will act as a multi-configuration wrapper also, which may allow the software to be installed on a variety of machine or different types of operating system. And it will try to test, it will try to validate and before installation. And once the basic requirements are met in that particular host, then the software will allow, the program will be allowed to install completely. And those type of testing will be completed in the installation testing. In a distributed systems, so principally the software is to be released into an already live target environment. Like for example, there'll be a change in the database schema, or it could be a kind of installation of a new software. So what they do, like in such circumstances, they may compromise the backup procedure, which will intended to the rollout to the target environment. And if the deployment is unsuccessful, there'll be rollback to the previous version. And for that, like ideally, they'll be trying to test the deployment plan and how the live environment will be. Like they'll be setting up a kind of a replica, the testing environment, and they'll be performing those tests. And next is about the integration testing. Like
one another point is missing here, sir. They are not talking about the operating system. They are doing the installation, right? Installation testing.
Yeah, it is there. Yeah, it is there in the. Yeah, it is there in the slide. Yeah, I will show that.
Oh,
Let
okay.
me know.
Okay, so
Yeah.
if it is there, maybe I.
Yeah, please. Yeah, please. You can supplement. You can supplement here. Here it is mentioned like the package software typically uses a setup program which acts as a multi-configuration wrapper, which will allow the software to be installed on a variety of machine as well as a variety of operating environments.
Correct, sir.
Because the user may have a different operating system.
Operating system, correct, sir.
Exactly. And you know all the reality, the challenges what you face in the real time, because the application will be developed for a particular operating system, and if the user is having a different operating system, so probably there will be the compatibility issue will be there.
Especially hardware and the operating system.
Exactly, sir. Exactly. You can add more points for that, sir. Yeah.
Yeah, actually, I don't have such a kind of experience, but this is more of testing the application against the hardware. So whatever the hardware they want to have, right? So they
Yes,
will be installed on
exactly.
the hardware and
Yeah.
see everything looks good, everything works as expected. And also they will try to test it on different operating systems like Linux, Windows, Unix, and other things. So
Yes.
that is where the installation testing comes into the picture. If there are any challenges that has to be fixed on the application. So the maybe client may be given kind of a requirement with the hardware. This is what the hardware we are going to use, and this is the operating system. So and also sometimes what would happen, sir, there will be some sort of a browser incompatibility as well.
Yes.
Sometimes it may also happen. There may be some
Yes.
possibility, basically kind of a user experience that cannot be
Yeah.
met because of the
Yes.
browser compatibility. So maybe the
Exactly.
alignment or the image, the loading of the image, that won't happen properly. So
Yes.
all those things has to be taken care as part of the installation history.
Yes, very good, very good, sir. Very good, very good. Sometimes even a program will be having a disclaimer. This program really works fine in
Files,
Firefox. This
file,
works
Firefox,
in IE version more than 10.
for example.
Yeah,
All
yeah,
those
they'll
things
be.
have to be tested, sir.
Yes, exactly, exactly, sir. Different platform, different browsers, and different environments. They'll be trying to test and see how the system is behaving in the overall manner.
Especially on the databases. So if they are doing any database schema changes,
Yes,
okay, on the patching, right? So that has to be
yes,
mm, tested very carefully,
yes, yes,
especially on
yes.
the tables. Yeah, so there may be some requirements on the upcoming release of something, so that they may have added some columns or they may added some constraints on the database, right? That may
Yes,
cause a problem as well. So
yes,
all those
exactly.
things have to be considered on the installation.
Okay, okay, very good, sir. And also they'll be taking a backup in case if they are making any changes to the database schema. Because if something goes wrong,
Yes.
even they'll be having the backup data with them
Yeah.
in a
The
failure
recovery mechanism is
scenario.
there. Yeah. Yeah. Always there will be a recovery mechanism. So,
Okay, okay, very good, very good. Kind of a
if
rollback.
they still roll back.
Very good, sir. Very good, sir.
Right.
Thank you, Mr. Shiva. And we are half the way through for today's session, and we'll take one thing we'll be taking a short break of 15 minutes from now for a tea break, and we'll resume the session for after 15 minutes time. And I'll be on mute for another 15 minutes from now.
Okay.
Thank you, sir. Yeah, 15 minutes. I'll be on mute. Welcome all after a short tea break. We'll resume the session. So before the break, we are discussing about the installation testing, and we'll try to continue the remaining topics. Integration testing, as we just discussed, once the individual software modules have been completed, the unit testing, then it will be combined and it will be tested as a group. So this is to evaluate the complaints of the system or the complaints of the various components, which is very specified for the functional requirements. I can say the business requirements. And this integration testing will be completed after unit and before validation testing. And validation testing also called as the system testing. So before that, they'll be performing this integration testing. And what are the various approaches we have for completing the integration testing? The first type is called Big Bang kind of an approach. And the second one is the mixed or the sandwich. Then the third one is a risky hardest. Then top down, bottom up. Some of the type of approaches which is used to perform the integration testing. And some other integration patterns of the collaboration, integration, backbone. So various integration testing is also available. So when it's a big bang, it's like most of the developed modules are coupled together to form a complete software system, or you'll be having the major part of the system that will be tested before the integration testing. And this method is very effective for saving the time in the entire integration testing process. And however, we need to record the results of those tests. Otherwise, you'll be having a difficult, there'll be a challenge to understand the effectiveness of the testing. So the primary challenge here is we need to record all the results properly. And bottom up, this is another type of an approach where they'll be testing the low level components first. Then once the low level components are tested, then it will they will be facilitating to test the higher level components. And this will be repeated until the component that is reaching the top of the hierarchy is tested. So all the bottom or the low level modules, the procedures, functions that will be tested, then they'll be integrating and forwarding towards the top level. So there's an approach of called bottom up testing. The next, top down. So what they do, like the first, the testing will happen for the top integrated modules that will be tested, and it will be branched out, and they'll be trying to test step by step until they reach the related modules, and they'll be completing all the modules. And third type, sandwich testing. It's a kind of a combination of approach of both top down as well as the bottom up kind of a testing. So based on the organization requirement, they'll be choosing various types of approaches. And one limitation to this sort of testing is that any conditions not stated in the specified integration tests outside the confirmation test, that will not be tested at all. So that will not be tested. That is one of the limitation. The next type of testing, regression testing. So when you say regression, it's a kind of rerunning the functional, the non-functional tests. So probably this will happen if there is a alteration in the source code. The system is running for quite some time and there are some changes have been made to the source code, and it will be followed by the regression testing. So this will make sure that any changes that is made in the program, kind of bug fixing, or it could be kind of software enhancements or configuration changes, it is not affecting the other modules or functions which is working fine in the previous version. Because sometimes change that is made in the software code that may impact the performance, or it can even affect the other functions or the modules. So from that perspective, the regression testing will be performed. So what are the various techniques that will be followed to complete the regression test? Retest all They'll be testing all the modules and the functions. Second type, you're going to select only few tests, right? Regression test selection. You're going to test only select certain modules and the tests will be performed only that. Then third type, based on the priority, prioritization, test case prioritization, and based on that, the top priority tests will be tested and the less or the low priority tests that may be performed in the later stage or that may be omitted in this particular testing stage. Then the last one, the hybrid. You'll be having one or more parameters that will be analyzed or that will be chosen by the organization to perform the testing. Retest all. This technique will check all the test cases on the current program, basically to test the integrity. And this will be very, very expensive. Also, you need to rerun all the cases. And one of the advantage in this approach is since you are testing all the parameters, all the modules, all the functions, there are no errors because of the modified code. You can ensure that there is no change happening to the running program, so that you can very well you can confirm, you can assure, since you are testing all the functions and modules, you can assure the organization. Regression test selection. This is like you're not going to test all, right? You're going to test only based on the selection. You're going to test, and this is one of the technique where you can minimize the time window that is required for the testing. Prioritization, again, this is to increase test suitcase rate of fault detection. You're going to prioritize based on the business requirement, and only that will be executed. And some of the test cases that may not be executed because of some lower priority that will be done in the following cases, or sometimes that will be even omitted during at that particular time. The test cases are done only based on the prioritization. General prioritization, version specific prioritization. There are few types of test case prioritization that is in use. Then hybrid, you'll be following one or more parameters. Acceptance testing, like it is used in the agile software development methodologies, particularly when they want to test on the fly, on the going, like accepting by the user community. Like they want to test a particular use cases, and based on the output and based on the behavior of the system, so they'll be trying to get the confirmation that the software or the application is working fine. And most of the acceptance cases will be done in the black box system tests, because the end user may not have the visibility of the software code. They may not have the visibility of the software design or the source code. However, they'll be having the proper interfaces to provide the input, and they'll be getting the output, and based on the outcome, based on the results of a specific module or the functions, then the testing will be evaluated whether all the parameters are working fine, or if there is any error, then it will be notified and it will be rectified before releasing the product. And here the acceptance testing, the customers, I can say the stakeholders, generally they are responsible for verifying. Generally the SMEs, a subject matter expert, will be a part of the testing team, and they'll be performing the test, and they'll be accepting based on the criteria, based on the test scores, and they will decide whether the test is a pass or a fail based on the output, based on the outcome of that particular test. And acceptance tests are also used as a regression test prior to the production release, and one of the mandatory test that cannot be omitted before the production of any particular application program. any new acceptance test that might be created for each and every iteration, and that will be reporting the zero progress. Like they'll be performing this test before releasing to the production. Different types of acceptance testing: user acceptance testing, or you can say the factory acceptance testing. So this will be done by the development team itself. You can say the vendor before releasing the product. That will be done by the development team itself, called as the factory acceptance testing, or even this can be called as alpha testing also. And second type of acceptance testing, this is at the destination site. I can say the SAT, site acceptance testing. This may be performed by the users at the site, and this is also called as beta testing. Beta testing will be done at the um, customer site or the user where they are using the application for their business. So there are two type of acceptance testing discussed here. One is the factory acceptance testing by the developing team, and the site acceptance testing by the users, performed by the users who are going to use the application. And operational acceptance testing or readiness testing. So this is to make sure that all the process procedures are in place, and how to that is required to maintain the system. All the checks that has been done, for example, backup procedures and DR procedures, and how about the training that is required for the end users, and how about the maintenance procedures for the particular application, the various security related procedures. So if all these have been in ready status, then they'll be performing this testing, like operational acceptance testing. Then there's about the contract and the regulation acceptance testing, because the testing is performed against a certain criteria that is documented in the contract before the system has been accepted. For example, it could be one of the government requirement, it could be one of the legal requirements, or one of the safety standard requirements, or it may be a specific contractual requirements for the organization. So they'll be trying to perform a test and observe whether it is fulfilling these requirements. In the factory acceptance testing by the employees of the supplier organization, and normally this will be done for both the hardware and the software, how this performs. Then alpha testing, beta testing, we already discussed. Alpha testing generally takes place at the developer site by the internal staff before it is releasing to the external customers. And beta testing, this will be done at the customer site, involving you'll be having a group of customers, maybe the pilot users for that particular application or a program, and they'll be trying to perform the test, and they'll be providing their feedback, and based on that, that will be released to the other users or to the entire organization. Often this is called as a field testing also. The beta testing, the site acceptance testing, the SAT, or the field testing. So basically the end users who are going to make use of the application or the program, so they will be part of that particular testing activity. Then alpha testing, we already discussed. Developer side, the tests that will be done by the internal team. And alpha testing in the software development lifecycle. You'll be having the unit testing, integration testing, system testing. After that, you'll be having the alpha testing. So basically, they'll be trying to even test the contractual requirements, the legal requirements. And then once the alpha testing is positive, or I can say successful, then that will be promoted to the beta testing at the customer site. This is the alpha testing. First phase, it will be performed by the software development team, and second phase, this will be provided to the quality assurance team. This is for additional testing. In the beta testing, as we just discussed, this will be done at the customer site. A limited audience will be there outside the programming team, so called as the beta testers. And this is about the beta testing. And some of the factors that depends upon the success of the beta testing, the test cost, as well as the number of test participants, the shipping duration of test, demographic coverage. These are some of the factors that needs to be considered when they go for the beta testing. Then combinational, when you say combinational, because it is not possible to test all the combinations. So what they do, like what is feasible for that particular application program. So that will be chosen as the types of various software testing that will be agreed by the organization, and they'll be performing those tests, the combinational testing. Yeah, they cannot test everything. So what they do, like they'll be trying to go for a combinational one, identifying the minimum number of tests so that they'll be getting the maximum coverage they want. So do we have any doubts, any queries in the topics, whatever we discussed? Else, let me bring up the next unit to be discussed. So next topics we are going to cover is log management. So basically a kind of log analysis, and what is the process that is used to identify, collect and retain the logs and the various types of logs, antivirus logs, IDS, IPS, remote access logs, and then the procedures that is used for log filtering responses to log alerts. So like that, we are going to discuss about the log management in the next chapter. So it's a log management. Basically, this will be dealing with large volumes of computer generated log messages. For example, this may be even called as audit records or audit trials or event logs. So what is happening in the local host? It may be from the application event, or it could be security events, or it could be a system events. So in a chronological order, the records will be stored on the local host, and that will be used as the log records. And log management generally covers log collection, so which will help you to record the logs. And also, like there are some arrangements where you can aggregate the logs in a centralized manner, where you can collect the logs from various devices. You can push it to the centralized log servers, and from there, where you can use many log analyzers, log filters, and you can perform the log analysis. And also, we need to know like how long the logs needs to be retained, how long the logs to be stored. For example, some of the transactions you need to make it available for last 30 days, or last 60 days, or 90 days, or even some of the other requirements will help you to know like how many days the logs that needs to be retained in case if it is required for any kind of an analysis or investigation in the later stage. And also the retention, then log rotation. because in some of the environments, so there will be a requirement to have the logs for the last 30 days. So what will happen to the on the 31st day? The logs that is collected on the first day that can be erased, and the 31st day log can be recorded, and 32nd day that day the log that is collected on the second. It's like kind of a log rotation. At every point of time, you will be having the last 30 days logs that will be retained in the system. So kind of a log rotation. Then analysis, this can be done in a real time also, and sometimes this will be done after I can say near real time, or maybe after a specific time, kind of a bulk after storage. If there is a certain requirement to perform a kind of a timeline analysis, what events that is happen in the device given a date and time. So they'll be trying to fetch the logs for that particular time window, and they'll be performing the analysis. Then also there are many tools available which will basically help you to search for a specific log, and also you can able to generate a lot of reports based on the requirements. So by and large, when you say log management, these are the various activities that will be happening in the logs. So the primary drivers for log management implementation are concerned about the security, about the systems and the various network operations. So what is really happening in the environment, and about the various interested traffic that is at that particular point of time, and the various events to fulfill the regulatory requirements. Because each and every computing device will have the ability to generate logs. For example, a particular user is trying to log in to the device, or if some of the applications that has been running, or if there is any system errors. So, in order to know what's happening in a particular device, logs that will be generated, and that will be stored in the host. And there are two options: either it can be stored locally in the file system, within the file system, or it can be pushed in the remote system. For example, you will be having a lot of centralized log servers will be there, and there'll be a scheduled the frequency of time. I can say every 30 minutes the logs can be pushed, or every 5 minutes it can be pushed, or even every minute. So like that, the logs will be generated in the local host that will be pushed to the centralized log servers for the various other requirements. And effectively, the analyzing the large volumes of divers can pose many challenges, because sometimes the log data can reach hundreds of gigabytes, right, even per day for larger organizations. And also it will be very, very challenging if you just simply collect and centralize and store. There needs to be a lot of like I can say the activities that will help to identify any kind of potential threats. Because if you start analyzing all the logs, so probably the major volume of the logs will be BAU activities. Like you may not find any threats within that, and some of the real threats may be very negligible if you compare the volume or the size of the legitimate traffic. So just simply collecting the logs and storing it may not help, and you need to use various triggers, various filters and analysis to drill down into get into the suspicious kind of activities, or kind of certain required parameters, so that you can make use of this log analysis in a more optimized manner. The first process, normalization, because various vendors will be involved in the various devices, and so the logs may be generated in multiple formats, in different formats, I can say. So the process of normalization, basically to provide a common output for analysis, because even though you collect the logs from various devices, for analysis you're going to use a kind of a single application or a single source. So from that particular source, you need to have a kind of normalized kind of the content. Then second, we need to know about the velocity, the speed at which the logs are produced from various devices that will be pushed. Right? So it will be very difficult to aggregate and to make an analysis. And the third one is about the veracity, because the log events may not be accurate in the sense like sometimes the IDS may record thousands and thousands of logs, but after investigation, you will come to know there could be many false positives within that. So the log events may not be even accurate. Sometimes it may be look like a kind of a threat, but probably it could be one of the known and the legitimate traffic also. So lot of activities and the analysis will help to make use of the data that has been stored in form of logs. And most of the cases, the organization will be purchasing many commercialized tools, which will help them to assemble, which will help them to analyze the various the open source components, because they will be getting a lot of technical information from the logs, which needs to be usable, and also uh, uh, which will help them to know about the various events happening in that particular host. Some of these logs may be non-business related events, or it could be a malicious events, or that need to be a suspicious events that needs to be identified, that can be analyzed or investigated later. And also they need to know which will help them to define whether a reported alert is real alert, or a false positive, or a true positive. And also sometimes it will help them to analyze and reproduce and solve many bugs, or sometimes the application program so may run in a different manner. They will be trying to identify a type of defects or bugs also. Even for that also, this will be used. Some of the terminologies that is commonly used in the log management, logging. So this is defined as a kind of an instantly discardable data. I can say on the technical process, could be from a specific application or a website, and it will represent the process or the data that is the user input. So that will be logging in the sense like it is recording, or it is storing the information. Then auditing would involve the data that is not immediately discardable. In other words, like we can say this is a kind of an ongoing auditing process. The information that is stored persistently, and that will be helpful to know about the user. Um, I can say the various events and the activities, and they'll be trying to identify the patterns of a particular attack that is happening on the perimeter infrastructure. For example, it could be it may happen. It may happen on a particular firewall, or it may be happen on a IDS, IPS, or a proxy servers, or even on any other servers. It can be on the file servers, or on the database, or on the application, or the web servers, and they'll be trying to identify any kind of malicious traffic, or even an attack also. Log analysis. This can help you to track and monitor the performance as well as the availability of the system, especially when you are using information assets where the availability is very, very critical for the organization. So what they do, like they'll be trying to monitor the performance as well as the availability of the systems. And most of these logs will be integrated from various business applications, and that will be logged into the log management systems. Because it can provide a kind of a single view, I can say, of a repository of these logs, where you will be having the complete view of what's happening in your environment. Organizations even merge the physical access monitoring and the logical access monitoring into a single view. So there are few integrated solutions are available where they can even integrate both the physical access monitoring as well as the logical access into a single view. And also they'll be trying to perform kind of a log analysis. So there are many reasons why they perform the analysis. There is to like why people are identifying, collecting, and performing the log analysis. First, they will confirm whether the system is functioning as per the requirement of the various security policies as well as the compliance requirements. And second reason, compliance with audit or with the other regulatory requirements. And the logs will help to perform the troubleshooting of the system. If some of the components are getting fail or they're getting a kind of warning or error, so it will help them to perform a kind of troubleshooting or debugging to know like which component is getting failed or which. So what is the actual root cause for that particular log, and also this will help at the time of forensics during investigations, or it could be a kind of incident response and security incident response. Finally, like these are the various specific reasons so why we'll be performing the log analysis. And also this will help you to understand the online user behavior. So probably the user could have triggered to run few applications or trying to connect to a different resource or trying to upload certain information like that. You will be able to identify the online user behavior when we go through all the logs. And generally the logs are generated by the network devices, the operating system, the running applications. You'll be finding the logs are nothing but a stream of messages in a time sequence. It will be written in the chronological order. And one of the important factor here is like all the devices on the network should be in sync with the time zone. I can say like the network time protocol. So basically that will be used to provide the time for those endpoints which is connected in the internet, so that all the endpoints will be having the same time without any you can say difference in the time factor, because the logs will be generated based on the local time on that particular host, and that will be pushed to the centralized server. And if there is a time difference between one device to the another device, and if the logs are generated and pushed to a centralized server, we may be missing some of the evidences, or I can say some of the artifacts, because there is a difference in the time factor. So very important here, like all the devices on the network should sync the network time protocol, and it should reflect that particular time in all these devices, so that even when we perform the timeline analysis, we can able to correlate. We can able to correlate all the activities that is been responsible, or I can say like the traffic that has been flowing through a device. So the time synchronization, the, the network time protocol, which is responsible for providing the time for the endpoint devices, are very important when we perform the log analysis. And usually the log messages will be interpreted and to understand about what is a specific event based on the source. Could be from the application, what's happening in that particular application, or it could be any security related events, or could be operations relevant events also. Sometimes the user will be triggering some activities, even that will be recorded in the system logs. For example, there will be change in the particular setting, that will be recorded in the system logs. Security event, I can say even log into the system, log off to the system, or removing some of the critical configurations. Like that, you'll be having the activities will be grouped or categorized, and that will be logged in the systems. And basically, logs are created by the software developers. So this is to help them in performing the debugging activities, and so that they can make a better understanding about how the users are interacting with the system. And also they'll be trying to read the log messages. Some logs will be vendor specific, and some logs will be application specific, and they'll be trying to identify like what is the particular event is about. Is it a authentication event, or is it a different types of events? They can able to interpret with those messages. And log message format may not be always fully documented. Like they'll be getting different types of formats. So it's very important for the log analyst to understand the complete domain where the messages are getting interpreted, because they need to know about the various different sources where they collect the messages, and it has to be normalized. It has to be normalized. For example, in one of the device, the error message may be called as ERR, right? In another message, it will be called as a notification. In another device, it may be called as error, ERR. So like that, you'll be having different terminologies that will be used in different devices. And some devices will be having an abbreviation, and some devices will be having the full form of the particular traffic or a categorization. So also the statistic, even the date and time format also. Sometimes it can be DD, YYYY in a format, and some devices can be month, date, and year. So like that, even the format also may change, the date format, and also the other terminology. So there is a need to normalize these logs before analysis. And also here the author is saying like some of the log messages from Windows, or it may be a Unix or network firewalls. So that needs to be aggregated, and it needs to be normalized. Because we just discussed, some of the different vocabulary can be used. ERR, or warning, or ERR or warn. Some systems will use just warn, or some systems will just reflect as a critical. So we need to know the various uh, text or the content that is used by different devices, and we need to normalize these terminologies. Then pattern recognition, some of the functions and technologies in log management. The first is about the pattern recognition. So this is like how to select the incoming messages when you compare with the pattern book. Is it is a kind of legitimate, or is it a kind of a suspicious? Is it a known pattern? Is it an unknown pattern? So how this can be recognized? For example, normalization, as we just discussed, could be one of the common date format, or it could be normalized IP address, how that has been represented, how that has been logged in. Then after normalization, it will be kind of a classification. Classification will help you to filter, to display, or to tag specific, I can say, the the activities. And for the classification, most of the vendors, they'll be using the event IDs. You'll be finding the specific event ID for a specific activity. So based on that, you can able to group, you can able to tag. And correlation like the logs will be collected from various devices. It can be collected from operating system. It can be collected from network devices. It can be collected from security devices. It can be collected from servers. So all these logs will be referring a single event. So we need to know how to correlate the logs that is collected from various devices, and how to reconstruct that particular single event. and it is usually connected with the alerting systems. And next topic, artificial ignorance. It's a type of machine learning which will help you to discard, which will help you to remove the log entries which are known to be uninteresting. For example, the artificial ignorance will help you to identify the normal traffic, and it will remove, it will discard those log entries. It's a normal BAU activities, right? And this will help you to detect any kind of anomalies in the working system. If it is a normal traffic, it will be ignored, it will be removed, it will be discarded. But if it is, there is a deviation, if it is an anomaly from the normal pattern, then it can able to identify this is a suspicious kind of an event or an activity which needs further investigation. So like that, that will help to identify any kind of suspicious events. In log analysis, like recognizing and ignoring the regular common logs. This is what we discussed in the artificial ignorance. It will try to identify there's a common log message which will be generated in the BAU. So there is no threat in that. So they'll be trying to remove, and if there is any new messages haven't appeared in the previous logs, or it could be kind of a signal for some critical events, some suspicious events, only those events can be qualified for the further investigation. In log analysis, even this is compared with the other analytical tools, such as APM. APM is generally for the specific application performance, not for the specific threats in the environment. APM, this is only for application performance, how the application is performing. And even this can be compared with that also, kind of even error monitoring in that particular system. Some functions will overlap in this to the log management and the application performance management. But APM, this is more on the performance of the particular application that is used in the production environment. And error monitoring, this is driven by the developers versus operations, because they need to know about how they can integrate the code and handling the exception blocks. So the next topic, retaining the logs. So how long the logs can be retained in the specific system? Sometimes the logs can be archived, and that needs to be kept for a particular defined period. So need to understand the various requirements, how long the logs that needs to be stored and that needs to be made available. And also you need to identify the performance trends, various security events, and also like you can able to pinpoint demands of various high demand for these logs. And archiving logs can drive the cost savings, which will allow you to extend the time frame in which you can use the log data to make many informed decisions. No need to keep the logs in the live service. You can archive those logs, and you can keep it in the non-production environment. And if there is a requirement, if there is a requirement where you can able to fetch those logs, you can make those requirements also. And for compliance reasons, archiving your logs ensures that you are completely protected. For example, some of the business related events you need to retain for certain years. That could be one of the business legal requirements, and that will be helpful for any kind of compliance requirements also. And data retention policies, this may vary from several months to several years, depending upon what type of service you provide and what type of standard or regulation that you need to comply within. Some might specify what is the minimum log retention periods. Almost that will require a kind of an audit trial, where if there is a requirement, then they can able to review those logs and they can make an analysis on that. Trend spotting. So this is to like if you aggregate the logs for a certain period, you'll be able to identify a kind of trend in a short term or a long term. So that will try to identify any kind of anomalies, or I can say any type of specific attacks, or I can say any type of particular categorization of events that is happening. Old entries may get overwritten, deleted, or lost. And then next, after log retention, so um, there will be process to identify like what logs to be retained for auditing purpose. Like you need to get into the various events which is related to security events, or sometimes it may be a application performance related logs, or it could be some of the system integrity related logs where you need to retain to fulfill regulatory requirements. For example, I can say like in probably from a different example, for the credit card industry, the credit card statement that needs to be retained for 7 years. So this is one of the requirement for credit card industry. So like that, each and every industry, they'll be having various business requirements. Based on that, they'll be trying to retain the data that is required in terms of any future requirements for any kind of investigation or any kind of an analysis. Next one, administrator activity. Any type of activities that is performed by the administrator account, or any type of administrator activities. For example, I can say like changing the system configuration, or even like adding a new group or adding a new user, or kind of any kind of an administrative activities, or like cleaning up a particular drive, or any other activities on a particular device, like any administrator related activities, not the user related activities. Then certain user actions, I can say could be a login, or any kind of specific commands. Then any kind of errors that is generated by the application or by the system, any kind of an exceptions or a warnings. All these things can be typically used to store as logs that can be retailed. And it is very important to retain the integrity of logs, even though the logs, so that will be stored in the text form. It is very important to keep the integrity of various logs. Also, we'll be having the logs in terms of any kind of hardware failure also. Sometimes if um, like some system may fail due to the hardware components, even that all information also will be recorded in the logs. Integrity of log, that is very crucial when submitting the evidence to the court, because even the log files also can be tampered with. So there should be a proper security requirements, making sure to hold the integrity of the logs. Importance of the integrity of logs, and different types of logs. What we have like event logs, then the transaction logs, then we have the message logs like internet IRC or IM programs. In case of IRC software, message logs will be having the messages that has been sent and received from the server to the system, and they'll be trying to identify the any kind of changes that is happening in the topic or users or status, like making the more as a combined message, like any changes that has been, right? And this is related to the IM messaging, the instant messaging. Transaction logs, and AV logs, the antivirus logs. So basically, the antivirus software that will help to detect, that will help to clean, remove, or neutralize some of the threats or the known malicious programs or scripts. And over a period of time, it will be logging the information like about any kind of a detections. For example, it could be a spyware or a Trojan or a worm. So based on the identification, it will try to record those information as a malware or virus logs, and also the status also, like whether the antivirus software able to clean or able to quarantine or any further action that is required by the administrator to clean the particular malicious program or a script. So this is how the antivirus software this works. And basically the antivirus software, it will be recognizing the virus by having the known patterns. And some of the threats, even this can be detected by using the behavior monitoring or the predictive machine learning also. Because not all the threats will be having the uh, specific pattern. Even behavior based detection also is possible in the antivirus software. It will be scanning a file or a program or an application, and it will try to compare a set of code with information that is stored in its database. And if it finds code that is identical or similar to that pattern, then it can able to consider that as a malware, and it will try to clean it, try to quarantine from the host. And it will be writing all the logs for all these detections. Whereas definitions, like it depends on the how it can able to identify the malware, and you'll be finding very frequent updates from the security vendors, and it will be containing the signatures. It will be updating this regularly so that the new malicious malicious program or the scripts also can be identified. And if there is any malicious script or the program that has been detected, then it will try to perform the actions. Either it will try to clean or delete or quarantine, and it will write the logs. And signature based detection, this is one of the common traditional antivirus software. So that will be checking all the executable files, and it will try to validate with the known list of viruses in the pattern. And if the pattern matches, then it can able to identify this. The detection is purely based on the signature that is available on the infected files, programs, and applications are basically scanned when they're in use. So a type of real-time protection. And we do have the scheduled scans also. So there are many types of scans available. The real-time scan, any new file that has been created or downloaded, right, or even copied at that particular time. So the real-time scanning profile that will help them to scan to detect any kind of a malicious scripts or programs. Then we do have the scheduled scan, where it can be a weekly scan, or it can be even a daily scan also based on the configuration. It will try to scan the targeted drive or the folder or against the set of known pattern, and it will try to detect any kind of malicious program. And we do have the on-demand scan, and we do have the other type of scans, which will basically to detect any kind of suspicious or malicious files or the programs, and to take actions. In heuristic based detection, again, like it is, this is deployed in some of the antivirus programs. So this is to detect any new or variant of an altered version of the malware. Even in the absence of a latest virus definition, this heuristics will able to detect that particular malicious script. Behavior based, this is based on the system behavior. Sometimes the memory of the system may be used to the greater extent, or the CPU resource, or it may try to connect to a different blacklisted domains. Like there will be behavior based direction, not on a specific pattern. And sandbox detection, the kind of the applications like that will be run on the kind of virtual environment. This is to track what kind of actions it performs, like any kind of malware analysis. So that will be done in the test environment. I can say sandbox environment, where they'll be allowing the malicious program to get executed, and they'll be trying to perform the analysis. Then data mining techniques. So one of the latest trends in detecting a malware, it will help you to find whether the program is malicious or not. The next topic is IDS logs, intrusion detection system. So greatly this system is used to monitor the various events that is happening in the environment, in the network level, and it will try to identify any kind of a deviation in the implemented security policies or on the standard security practices. It will try to detect any kind of an intrusions that is happening on the environment. And we do have the network based IDS, NIDS, and the host based IDS also. It will try to detect any kind of an intrusions on the specific environment, and it can generate the logs. It will lead to an alert, right? It can even trigger some of the alerts, and basically the IDS will help to detect the intrusions, and it will log, and it will trigger the alerts. Log generation, individual hosts, it will try to generate the logs and push it to the log service. And log analysis and storage will happen like logs received from various hosts and devices. This is for analysis outside the host. Usually the storage will happen in the outside the storage, and monitoring this will help to in automated way. It can help you to monitor the intended traffic or the network for any kind of an anomalies or any kind of a malicious traffic. And logs are made available in the log servers depending upon the log type, the host, and the various network controls. The logs will be analyzed, and this can be either transferred in the real time or in the near real time, because some of the devices will be pushing it from the, I can say, like it will be pushing it from the real time manner to the centralized logs servers, or sometimes it will be near real time. I can say like as a batch of probably every 10 minutes or every 15 minutes or every 30 minutes. So that will be based on the configuration that will be pushed. It's a kind of a batch on a particular schedule. And there are a few ways where we can perform the log analysis. Like will be automated manner, we will be converting the logs from multiple formats to a single standard format. Because for analysis, like you need to have the single normalized, I can say, the format that can be done over the automated manner also. Where log monitoring will help you to monitor various console in automated manner. You can able to generate various reports, the dashboards, and even filtering. This is another log functions. If you are very specific to analyze a particular event, what you can do, like you can provide the event ID so that only those events will be filtered and that will be made available so that you can perform the analysis. And event aggregation from various devices, not only from single device, different devices you can able to correlate and aggregate for a particular event, and you can perform the analysis. And on the log management side, on the storage, you can think about the log rotation. So what is the retention period that is required for this particular logs? 30 days or 60 days or 90 days, even 6 months or 1 year. Until then, the logs will be available, and after the period is getting expired, then you will be finding the log will be rotated on a rotation basis. Then archival, compressing the logs and then archiving it and storing it in the offsite storage. Then log reduction based on the requirement. You may not store the entire logs, probably some of the reduced content or information which is critically required for the analysis. Then conversion, the format conversion basically, normalization, and also the control to protect the integrity of the log files. So these are the various activities that will be coming under the log management on the storage side. And what does an intrusion detection system do? So basically, you'll be having the network-based intrusion detection system and the host-based intrusion system. And most of the cases, the network intrusion detection system will be a hardware kind of a thing, and host-based intrusion detection system will be a software-based one. And we do have the signature-based detection, anomaly-based detection, any kind of a deviation, then it can be detected as a kind of a potential intrusion. So what are the various benefits we get from the log management? So we can able to detect or prevent any kind of an unauthorized access. And log analysis will help you to meet the regulatory requirements, and it greatly helps when it comes to the forensic investigation, forensic analysis for any kind of an attacks or any kind of a breaches after the event, and also help you to correlate the various logs collected from multiple devices on the network, and to make sure to comply with the regulatory requirements and track the suspicious behavior of a particular user or some suspicious activities on a particular server. You can able to track. Then also helps the IT support team, the troubleshooting and the network operations team. Based on the logs, they may come to know about various types of errors. Then monitor the user activity. Some of the best practices of frameworks, COBIT, ISO, ITIL, recommend to have the log management practices so that that will help to analyze the events, then delivering the reports to various departments based on their requirements, measuring the application performance, then achieving the ROI or cost reduction in system maintenance basically. So these are the various benefits. I can say the importance of conducting the log management. Then IPS logs, we just discussed about the IDS, intrusion detection system, and we do have the intrusion prevention system, which will prevent the future kind of an intrusions, and it can even identify any kind of vulnerabilities or problems within the security policies that is implemented, and it will help you to detect any kind of a violation in the security policies. Also, this will even help to reconfigure. For example, it will even IPS, I can say IDPS, intrusion prevention system. Even it can even reconfigure a firewall rule so that the malicious traffic may not be permitted again in your corporate network. Then after IPS logs, then we have the classification. It may be a network-based IPS or wireless intrusion prevention system, HIPS. Again, detection method, signature based, anomaly based, then stateful protocol basis. It can able to identify many threats. Then remote access logs. It's one of the remote access is one of the efficient and comfortable way for corporate to remotely connect to the system, basically to install, configure system software, and also even for troubleshooting also. And it is also very important to know about which user is currently having the remote access to that particular resource. It's very important to record the remote access logs and to review whether those access are legitimate or genuine to business. This can be even used for review as well as for the auditing purpose. And these logs are cut as the remote access logs. Some of the advantages of having the remote access logs: easily monitor. You can control and maintain various devices that is connected to a network. It can also help you to quickly troubleshoot using the remote access. You can define the access rights to files, folders for different categories of users so that they cannot misuse their access levels, and support the business growth by providing the quicker access to files. When you have the remote access, you can able to access those files, folders, the resources, and for troubleshooting. So some of the advantages when we have the remote access, and this is about the significance of having the remote access logs. The details are very critical for any digital forensic investigation purpose. It was very critical because it will help you to know about which user accessed the particular network or the server or host, and also you'll be having the date and timestamp of the remote access activities. You'll get to know about the origin of the event, the IP address, the MAC address, or the port numbers. You're able to identify from the logs, and also the status of connection also, whether they're still connected or the session is completed. Like you'll be having all this information of that triggered activity also. Is it a successful one? Is it a failure? In the web proxy logs, because the proxy server will be acting as an intermediary for requests between the client and the servers, and which will provide the resources. On behalf of the client, it will be requesting for the service, and the objective is to mask or to hide the origin, I can say the true origin of the request to the resource server. So like this, it will be acting as a kind of a middleman between the client and the target. So do we have any doubts, any queries? Some of the basic functionalities that is provided by the proxy servers. It can even provide the basic firewall and basic network filtering. It can help for network connection sharing, data caching. It will allow to hide, consider and make your network ID anonymous by hiding your IP address, so that the devices which is outside your network from the internet, they may not have the internal details of the client or the endpoint which is requesting this particular service. The main purpose of having the proxy servers, this is to monitor and filter the traffic, then improving the performance, helping in translation of the required services, and also for the security purpose. So do we have any doubts, any queries in today's session, whatever topics we discussed today? We are coming to an end of today's session.
Yeah, Ramesh. So have we covered all the portion on this paper, or still
Almost
anything?
Yeah, almost we covered. Almost we covered. And the last unit will be having like scheduling of tests and then validation of the test results. Apart from that, we covered all the topics. Yes. And whatever material I just gone through, it is taken from your courseware. Probably only the pictures I'll be taking from the internet search. Apart from that, all the text I have taken only from the courseware.
Okay. Yeah.
Any doubts or any queries before wrapping the session today?
No, sir, we are good, sir.
Okay. Okay. Thank you. Thank you all for joining today's session. And thank you, ma'am, for this opportunity. Thank you all. Thank you.
Thanks.
Thank you.
Thank you.